In this video, we're going to talk about maximisation and minimisation using differentiation. So our first problem is about a ball which has been thrown with this function. T represents time, and this represents the vertical height of the ball. We need to find where the maximum occurs using two methods. One method is differentiation, and one method is a method we've learnt before. So let's do it using differentiation. First of all, we need to differentiate the function. So if a question's asking you about the maximum or minimum, it often will say using differentiation. If it says using any method, you can choose which method you're going to use. So differentiating this function, you might want to pause the video before I continue. Welcome back. We are going to have the following. We are going to imagine, before we differentiate it, this is our graph of our ball. And in order to find where the maximum height occurs, we want to find out what happens at this specific point. So differentiated function becomes 20 minus 10t. But that's not the end of our problem. We need to decide, well, the differentiated function gives us the straight line or the tangent at this particular point. But at this particular point, the gradient has got a specific value. The gradient is 0. So we're going to work out when does this differential function or the gradient function equal 0. So what we have to do is solve this equation. And this is quite straightforward. We just move the 10t to the other side, and then we divide both sides by 10. So we get that t is equal to 2. Nice and straightforward. This means that the time, which is on the x-axis, and the vertical height, let's call this VH, on the y-axis, we're going to be able to find out that the maximum occurs when t is 2, and therefore what we can do is we can just substitute the 2 into the original function and we can get what f of t is going to be, or VH. So f of t is equal to 20 times 2 minus 2 squared. So that's going to be 40 minus 20, so that's going to be 20. So we're going to say the vertical height will be 20. But of course, there are other ways of doing this problem, which you won't use in the differential topic, but you might use in other topics. So for example, we can do it using minus b over 2a, like we've done before. So what you do is you take the formula minus b over 2a and you label it a, b, c. This is going to be a, this is b, and c is 0. Because we've got no added number here. And then all we do is substitute into this formula. So we have minus b, so we have minus 20 over 2 times a, which is minus 2 times 5, which is minus 10, which gives us 2. So like we did previously, we know that the x-coordinate, or the axis of symmetry, which is minus b over 2a, is 2. And then to find out the y-coordinate, we would do the same method as we did here, so that we get 220. So as before, we would get exactly the same coordinate. Now there's a third way you can do this, which is on the calculator, and I'm going to show you that now. So bringing the calculator up, we are going to type in our function, which is 20t minus 5t squared. So we're going to have 20x minus 5x squared. And then looking at that particular function, what we're going to do is we're going to press graph. And there is our function. And we just want to find where the maximum occurs. So we press second trace, maximum, number 4. We select to the left of the maximum. Then we select to the right of the maximum. And then we just select in the middle. As easy as that. So then we get the maximum occurs at 1.9999. You can see that's supposed to be 2, 20, 2, 20 as before. Now, we're going to go on to a bit more of a difficult problem. And the reason why this is more challenging is because we've got a cubed. So the first thing we're going to do is we're going to use differentiation as we did before. So let's do this. First things first is the graph is a cubic graph. Now, we don't know whether the graph has a minimum and a maximum, or a maximum and a minimum. So this one has a maximum then a minimum, but it could possibly have a minimum and then a maximum. So we don't know if it's going to be something that looks like the red graph or something that looks like the green graph. And this is why differentiation is quite useful. So with all these questions, when you want to find when a minimum or a maximum occurs, you need to differentiate and set equal to 0, because the tangent is always 0 at these black lines. So we get the original function, and let's differentiate that. So we are going to have f dash of t is equal to 30 minus 12t plus 3t squared. Now, the problem with this kind of question is it's a quadratic. So when we set it equal to 0, we're clearly going to have two places where a minimum or a maximum occurs. And this is because we have got two places in a cubic graph where we do have a 0 gradient. The red option, we have the two circles there, and the green option, we have the two squares here. So what we need to do is we need to solve this quadratic. There are multiple ways of solving this quadratic. You could use the quadratic formula. You could use the polynomial root finder on the calculator. But what I'm going to do is I'm going to show you how perhaps I would do this question. Imagine that this differentiated function is a quadratic. We know that because it's got a quadratic here. Now, to solve where this equals 0, we need to find what we call the roots. So I'm going to just put this on the calculator and find the roots. So we open up our calculator, we press y equals, and we're going to type this function in. So we're going to have 30 minus 12t, or 12x plus 3x squared. Then we're going to press graph. And we can see the cubic is much higher than we anticipated. So we need to make the y max much bigger. Let's make that 100 and see if that improves what the graph looks like. We cannot see the whole minimum and the maximum. And actually, we can see a problem here. We can see that this quadratic doesn't actually solve properly. And I was mixing it with the previous function. So I was saying that this function is to do with, and you would notice that the differentiated function is 3 minus 12t plus 3t squared equals 0. Now, you may have noticed I changed the question slightly in this answer. So instead of 30, we've got 3. But that shouldn't make much of a difference. So what we're going to have a look at now is solving this equation, because we want to find out when these minimum or maximums occur. They occur at 0, but we need to solve this equation using whatever method we want. We could use the polyroot finder on the TI-84, we could use a quadratic formula, or we could use a method perhaps more of you are familiar with, which is what I'm going to show you. What we're going to do is we're going to go into y equals, and we are going to create the function 3 minus 12t plus 3t squared, which I've already done. And then we press graph. And you can see we have a graph here. And what we need to study in this graph is where the two zeros occur. And this is because where the two zeros occur will represent the two x points of this graph where we have a minimum or maximum occurring. So let's do that. So we're going to press second calc 0, which is number 2. Then we need to go to the left bound of the 0. The 0 obviously is where y is 0 and where it crosses the x-axis. So we go to the left of the 0, we go to the right of the 0, and then we go on the 0. So our first 0 is 0.2679. Let's copy and paste that answer for later. Then we're going to do the exact same thing with the next 0. We press second calc, we press number 2, which is 0. We go across to this, to the left, to the right, and then on the 0 itself. Perfect. We now have two different types of 0. And I'm going to discuss with you what this actually means in terms of our graph. So returning back to our sketch from earlier, we can see that differentiating and then solving it once setting it equal to 0 gives us the two positions where we have a maximum or minimum occurring. We're going to say, therefore, that the maximum or minimum occurs at 0.268. That's rounded to three significant figures. And then the second maximum or minimum is going to occur at 3.73. Now, we have done differentiation. Now we need to prove that this is indeed where the maximum or minimum occurs using a sign diagram. Now this sounds a little bit complicated, but actually in practice you're going to find this okay. So what we're going to do is we're going to refresh the page, get rid of some of the information, and just focus on the key bits of information we want. So we've done the differentiation, we know the facts. I'm going to get rid of the information about the ball as we know that already. And at the moment, we're not going to be focusing on using the graphing calculator. So what we will do then is we are going to talk about proving this is indeed where the maximum occurs. And this is the most essential part of the lesson. So let's imagine that at 0.268, the red curve is true. If the red curve is true, we are going to have a maximum and then a minimum. If we've got a maximum and then a minimum, we're going to have positive, 0, negative. That would be our sign diagram. So we're going to predict this is going to be positive, 0, negative. And we're going to see if this is the case at 0.268. And then what we would do is we would predict to see at 3.73, because we think there might be a minimum, there's going to be a negative, 0, and then a positive. And then we're going to say that's happening at 3.73. And you're probably thinking, what on earth am I talking about? Well, let's show you with a calculator. So we're going to get the differentiated function, which we've used already before, the 30 minus 12t plus 3t. And we're going to study the table itself. So we are going to get onto y equals, and we're now going to press second table. And we're obviously going to start with much smaller numbers because we're studying what happens when x is 0.268 and 3.73. So I could scroll up the table, or another alternative is going on to table set, second window. We're going to start the table at 0 because we want something near 0.268. And interestingly, I am going to make this go up in smaller numbers because these are quite intricate decimals and they're quite close to each other. So we're going to say that this is 0.5. This means that the table is going to go up in 0.5s. Press second table. Brilliant. So we can see whether this statement holds true. Is the red graph true? So let's go for a number which is a little bit smaller than 0.268. And then we'd have to go for a number which is bigger than 0.268. So we can see that either side of 0.268 we have a positive gradient and then we have a negative gradient. So that indeed suits this. It has a positive gradient at 0 and then a negative gradient at 0.5. So it does have a maximum and then a minimum, and we can prove that with a 3.73. Let's go to the numbers either side of 3.73. We have a negative gradient, which would be this part here, and then we have a 0, and then we have a positive gradient. So what you have to do is something called a sign diagram to prove that this is the case. Now in the exam, if you're running out of time, what you're going to do is you're going to just guess. It's either going to be option 1 or it's going to be option 2. It's going to be positive 0 negative or negative 0 positive. And we're going to say that at 0, it's going to be positive. At 0.268, it's going to be a 0 tangent. And then at 0.5, it's going to be a negative gradient. Now, in the mark schemes, it doesn't really require you to do much more than that. However, I would recommend you write a quick sentence so you show to the examiner you know exactly what you mean. So what we would say is that at 0.268, I believe there is a maximum because the gradient of the tangent at 0 is positive and the gradient of the tangent at 0.268 is equal to 0 and the gradient is negative at 0.5.